Now let's see how to make the interfaces 8 LEDs using 8051 microcontroller. So what we are going to make here is actually connecting 8 LEDs to this port 0, all the 8 lines. So we have connected here. So as you see, the kind of the connection that was actually made is, so for this 8051, so port 0.0 one LED is connected and grounded. So similarly 0.1 you take another LED, again so on, it's connected, grounded, so on till the last P0.7 also one more LED is connected. So 8 LEDs are connected in this way. So usually port 0 initially made 0, just it is made as all the LEDs off. Once you do that, then load the accumulator 00, and this is loaded because we need to turn off the LEDs. So values here once loaded 0 makes it off because there is no current flow. So only when you make it 1, then this becomes on. So 1 makes it on, 0 makes it off. So that's a simple technique here. Accumulator is loaded with 00 and LEDs are off, and here it becomes off and here it becomes on. We are making it FF, and in between a delay is calculated. So this delay is calculated as a function. You see here delay program is written here. Once the LCall delay routines are called, it comes to this routine and this will be executed. So delay is generally for a fixed amount of count values are loaded, that is FF and FF. There are two registers which are in a nested loop, so which will decrement one after the other. So this R1 is the inner loop. It decrements FF times. Once it's completely decremented, it comes back and it decrements R0 by 1. And again R1 is reloaded, so on. So there is a way to calculate this delay program. So that will be explained in the next. So what we do here is the time the delay calculation generally made here as you can see here. So this is the delay calculation. So procedure is something like this. So there is a looping. So this 2 into 255, this is for the DJNZ instruction. So 2 machine cycle is for the DJNZ instruction. So what this 2 indicates here, it is for DJNZ. This is for the DJNZ instruction. And here is one more 2, that is for another DJNZ instruction. This is also for DJNZ. So this is for the inner loop. Okay, this is for DJNZ R1 and this is for R0. So what happens here? DJNZ R1 is called 250 times, and once it is completed, DJNZ R0 will execute once along with that reloading move instruction. This is for the move instruction. Okay, and that will be repeated the R0 times, that is 255 times count. Plus 1 is the initial move instruction. So total machine cycle is calculated using this will give the total machine cycle. So once you get the total machine cycle, now you know the relation. One machine cycle is 12 clock pulses. So I can calculate one machine cycle always 1.085 microseconds. This is actually a standard which we know already. So just to make a count value, what is the total delay? So 1.085 into total machine cycle will give the delay. So this is the total delay that was generated, so 0.142 seconds. So if I call this multiple times, then I can get a more delay. So this is how the delay calculations are made in using the nested looping of 805.